Quake kills 25,000 in Armenia. Quake toll rises to 240,000 in China. Killer quake takes 40,000 lives in San Francisco. Such headlines, though few and far in between, are not rare in newspapers. Such earthquakes have been among the greatest natural disasters in the history of human civilization. Earthquakes in the Garhwal Himalayas region, Gujarat and Latur in recent years have remained etched in our memory for the colossal tragedy and endless misery that changed the course of life of those affected. It is common to hear about the loss of life and property whenever there's a major earthquake. But seldom do we hear about the damages caused to the vital infrastructures like a nuclear reactor, power plant, a hydel power station, or even a strategically important defense installations, etc. First of all, such important infrastructures are not planned and erected in a seismic zone that is prone to earthquakes. The machinery and equipment and the entire structure is tested for seismic tolerance. The vital facilities are made quake-proof. Even if an earthquake of greater intensity rocks the region, care would have been taken to see that the damage is minimized. How do they do it? The Earthquake Engineering and Vibration Research Center at the Central Power Research Institute at Bangalore takes care of all such critical needs.
CPRI was established in 1960 by Government of India under Ministry of Power. At that point of time, it was established, one at Bangalore, the other at Bhopal. In Bhopal, it was Short Circuit Development and Testing Center. Subsequently, number of laboratories came up in Bangalore and Bhopal, and in 1978, CPRI became autonomous. It also established centers at different places in the country. It was at Nagpur, where it was for thermal research and development purposes, UHV Research Laboratory at Hyderabad, Energy Research Center at Thiruvananthapuram, Regional Testing Laboratory at Ghaziabad, and Fly Ash Utilization Center at Raichur.
One among its many engineering and research facilities is Earthquake Engineering and Vibration Research Center at Bangalore.
Equipment structures are subjected to vibrations. One of the major causes of vibration is earthquake. Earthquake is a natural phenomenon. It cannot be predicted or prevented. Hence, any equipment which is placed on an earth, it is going to face the earthquakes. In this respect, it is necessary to see that the equipments are subjected to seismic qualification before putting to the system. In this respect, CPRI has established an Earthquake Engineering and Vibration Research Center to cater the needs of the industries and the manufacturers, to see that their equipments are capable of working even after the earthquake happens.
The Earthquake Engineering and Vibration Research Center is equipped with necessary facilities for providing testing, research, and development and consultancy services in the areas of seismic and vibration, qualification of instruments and equipment, and other generating stations are also tested and qualified as per national and international standards. Besides this, the center offers consultancy services in checking the design adequacy of structures and bridge models, etc. for seismic qualification. The facility for seismic qualification of equipment consists of a Traixal Sheakar system with 6 degrees of freedom with the state-of-the-art 128-channel data acquisition system, experimental model analysis software and finite element analysis softwares. The main features of the Traixal Sheakar system: it has a table size of 3 square meters. Mode of axis: triaxial, namely X, Y and Z. Degrees of freedom: 6. 3 translatory and 3 rotational motion. Payload can be 10 tons. Maximum height of the specimen 10 meters. Axis X has a displacement of plus or minus 150 millimeters, axis Y plus or minus 150 millimeters, and in the Z-axis it is plus or minus 100 millimeters. Velocity in the X-axis plus or minus 1000 millimeter per second, in the Y-axis plus or minus 1000 millimeters per second, and in the Z-axis 1000 millimeters per second. Acceleration would be plus or minus 1 g in the X-axis, plus or minus 1 g in Y-axis, and plus or minus 1 g in the Z-axis. Frequency range from 0.1 to 50 Hz. Yawing moment 10 tons M. Overturning moment 40 tons M. Actively controlled 6 degrees of freedom. The system consists of 4 vertical actuators and 4 horizontal actuators. An equipment which has to undergo seismic qualification tests is brought to the center. The sample is fixed to a fabrication system. It is placed on the seismic table of the Traixal Sheakar system, which involves computer-controlled precision and accuracy. The sample is tested for all the 3 axes, namely X-axis, Y-axis and Z-axis. It involves 3 translatory and 3 rotational motions. Later, the same model is tested under working conditions for 30 seconds. The duration of the shake during an earthquake would normally be between 5 to 6 seconds. But here, the sample has to undergo a rigorous test for 30 seconds. After the test is over, the damage is inspected, analyzed, and a report in the form of a qualification certificate is given. The testing Traixal Sheakar System facility conforms to the IEE 344, IEC 600 68/3/3 and other international standards.
The power equipments which are used in the atomic power plants and hydro plants require certification under seismic conditions. The facility established will help in designing the equipments and structures to meet the requirement of the earthquake standards, both national and international. In India, we have been experiencing lot of earthquakes, and in order that the safety and security of the personnel and equipments are maintained, it is very essential that these equipments are tested in the laboratory simulating the earthquakes. This laboratory helps Indian industries to design and manufacture the equipments to meet the standards. Without this facility established at Bangalore, people used to go abroad for testing, and it was resulting in foreign exchange drain, and also the facilities were not available as and when it was required by the users. So with the establishment of the facility in Bangalore, Indian industries, research organizations and the countries around India will be benefited very much, and the laboratory will be able to stand on its own leg.
The center is capable of performing a diverse range of vibration tests on equipments, sub-assemblies and components. The dynamic laboratory houses a vibration test system which is used for the design of components and equipments and experimental verification of their safe functional capability under vibrational and shock loads in accordance with the national and international standards. The climatic chamber with vertical vibration interface and thermal barrier facility is useful in examining the behavior of the components or infrastructures when they are subjected to simultaneously change in temperature, humidity and vibrations. Drop testing facility is capable of studying behavior of equipments when they are subjected to mechanical drop or sudden jerks during transportation. It is a computer-controlled equipment with a built-in calibration facility. Single-axis actuator with digital controller equipment can be used to carry out fatigue and dynamic characteristics of electrical, mechanical equipment and transmission line systems and components weighing up to 100 kgs. With these testing and qualification facilities and consultancy services in quake-proof services, the Earthquake Engineering and Vibration Research Center at the Central Power Research Institute, Bangalore, is safeguarding the country's vital structural facilities from earthquake and such other disasters.